Long time ago, okay, maybe not so long time ago. I'm talking about few years looking back on the IT market. The IT infrastructure in most organizations was completely owned and managed by each organization. It was usually on-premises IT deployment in one or maybe two data centers where almost all applications were running inside organization data centers. Any software application that was used inside the data center was license based and also used specific physical resources like servers, network connection, bandwidth, and storage capacity. The IT team was doing and controlling everything, planning what kind of hardware will be needed in the upcoming years, and then started a long purchase process to buy this very costly hardware setup, install that in the data center, and of course configure and operate those resources for the benefits of all end users in the organization. Basically, it is quite logical life cycle: plan, buy, install, operate, and start all over again when demands are changing. The organization must invest in hardware, software, ongoing upgrades, maintenance, support, customization, and of course, manpower. And all of those items are translated to money, the capital and operational costs that are associated with handling IT. Now, this traditional IT model was quite good for many years, and we will be able to find many organizations that are still operating in such mode. Now, something very useful we need to define and use as early as possible is the concept of application workload. Any software application that is running and performing a specific work consume resources like processing CPU, memory, network bandwidth, etc. The consumption of resources can dynamically change according to the behavior of the specific application. Think on some email exchange servers. As more users are connected to the email accounts, then the load on that email application is rising, consuming more resources. Measuring application workload is important, and it is used for a variety of use cases. Basically, we would like to know if the allocated resources are good enough to the application load. If something is not right, we can do something about it. For example, when you consider to buy a new laptop, then probably you will be able to find many application workload tests being performed to evaluate the hardware performance of that specific new laptop. So in such case, a defined workload can be specified as a benchmark when evaluating a computer system in terms of performance. How easily the computer handle the workload, what is the response time for a user request, and how much work is accomplished over a period of time. Another example that is more related to our subject is to measure all kind of parameters on the hardware equipment running a specific application, helping to evaluate the load in a given time. It can be the CPU and memory workload, input and output throughput, available storage capacity, network bandwidth, and so on. Now let's start to use the concept of application workload in the context of traditional IT. If you will ask some IT manager, his or her biggest challenge is the problem of resource allocation. At the end, there are limited amount of physical resources that can be allocated. The IT team bought a specific amount of servers based on limited budget, and the servers were divided to the application workload running in the data center. As a simple example, here we have two applications, A and B. The vertical line on the left side is the application workload over time. In addition, for application A, the IT team allocated 2 servers, and for application B, they allocated 5 servers. Now, looking from left to right, we can see the application workload patterns in specific time interval. Let's assume this is over the last 24 hours. Now, you are the IT manager. What kind of problems do you see here? Think about it for a few seconds. There are two main clear problems we can see here. The first one is that during the peak time, application A and application B are using almost all allocated resources, reaching the limit. Okay, application A is reaching the 2 servers maximum allocation, and application B is reaching the 5 servers maximum allocation. They can't grow and expand to additional resources. This was the allocated resources for each one of them. In that case, this problem is called overutilized resources, as during the peak time, the resources are becoming a bottleneck. The second problem is called underutilized resources. It can be on average, for example. Take a look on this point. The workload on application B is almost 0 or very low, and in parallel on the same time interval, the workload on application A is at the peak point. Now, it is quite obvious that it makes sense to utilize the unused resources allocated to application B and move them to application A just for this time period. But assuming those applications are running on separated servers, the resources cannot be shared, and most of the time they are actually underutilized in idle time. Now imagine you have 200 servers in the data centers running 100 applications, and we have much more complicated situation. The good news is that this problem was solved to some level using a new imported technology that was developed for helping to optimize the usage of resources inside the data center. I assume you're already familiar with the concept of virtualization, so I will explain that quickly. Virtualization separates resources and services from the underlying physical delivery environment. Now, with this approach, we can create many virtual systems within a single or multiple physical system. If we have physical resources like servers, storage, and network devices, we can use a virtualization management layer that is called here hypervisor, sitting on top of the physical resources. Now, using this hypervisor, we can divide the underlying physical resources to multiple virtual resources, also called virtual machines. Each virtual machine is like a dedicated virtual container with specific operation system and specific application running inside. The move into virtualization technologies was a useful evolution for traditional IT, of course helping to handle the issue of more dynamic resources usage and ongoing optimization across the data center, making the IT infrastructure much more efficient and flexible. It will be very hard today to find any data center worldwide that is not using virtualization technology. Now, everything was fine until the internet or the World Wide Web completely changed the way application and services are consumed. And this is the subject of our next chapter.